Hello everyone and welcome back. I got a question here, problem number 7, about a couple of submarines. And I've pre-written some of the information in parametric form here, but would like to read through and explain a little bit about what I did. So 2 submarines, A and B, have their routes planned, so their positions at time t hours from 0 to 20 would be defined by these position vectors. Okay, so submarine A starts here, obviously a depth of, what is this in kilometers? So it's 1 kilometer underneath the surface. I don't know where the point of origin is, maybe some dock or some docking station. Whereas submarine B is 2 kilometers underneath the water, and it looks like it's rising in its depth, and this one is plummeting in its depth. And then, of course, our X and Y components are changing as well. So we want to show that the submarines would collide at a point P. Now, this is really nice that they give this word collide to us, and we're showing that because now I can consider T the same variable when we know that there's going to be collision. Otherwise, I might have to assign, a lambda and a t or an s and a t, whatever that might be. But what I want to do is I want to find the time where the x components and the y components, the x components are the same, as well as the y components. And really, I only have to do this for, I guess it's saying show that it would collide. So I have to go all the way through it. And it's not just asking for the coordinate. If asked just for the coordinate, you wouldn't have to show all of this. You just have to find the time at which any one of the 3 components is equal. So I'm going to go ahead and just kind of finish up writing here so I don't distract myself. I just got done playing a game of Mario Kart. I got 4th. I know, pretty sad. Okay, so it looks like if I solve in my x component, I'm going to get 2 equals 0.5t, which means t equals 4. I'm going to plug in a 4 in both of these and see if they're equivalent. If I plug a 4 in here, I get 8 for the first submarine's y component, and I would get also an 8 actually here for the second submarine's y component at t equals 4. And then likewise, if you did the algebra here and you plugged in a 4, this would be -1 minus 4 times that was 0.6. And over here you'd get -2 plus 0.4. It looks like you get -1.6 is equal to -1.6. So the submarine A collides with submarine B. Sub A and sub B collide when t equals 4 hours. Okay, so now we have to find the point. So all I would do is I'd pick either the submarine A's components or submarine B's. I'll take A's. It looks like some easier math for the most part. If I plug in a 4 for T, actually I think I already have all this information. Yes, I do. Look at this. This is great. We already confirmed that the x equals 2, and 2. The y value equals 8, and the z value equals -1.6. So that is the point P where those 2 submarines will collide. In part B, it says, to avoid collision, submarine B adjusts its velocity. Show so that its position vector is given by the following. Show that the submarine B travels in the same direction as it originally did. Okay, so in this one, all we want to show is that the original direction vector, which was this, negative 0.5, 1.2, and 0.1, is a scalar multiple of this new direction vector. All right, this new direction vector is negative 0.45, 1.08, and 0.09. Now, if this scalar multiple were, I guess, m equal to 0.9, the two vectors would be equivalent. Therefore, we could say, I mean, clearly that they're headed in the same direction, just at different speeds, and that the new speed is about 90% of what the old speed was. So, all right, so its velocity is changed. Let's look at part C. Part C is asking us to find the value of t when submarine B now passes through P. Okay, so now that it has changed its velocity, and we knew that point P was the point positive 2, comma 8, comma negative 1.6. So I made a boo-boo. Earlier, P's point should have been negative 2, comma 8, comma negative 1.6. So I apologize if you noticed that earlier and you were shunning me the rest of part B into part C. I apologize. So that's point P. So what we want to do is show that what the time would be for submarine B to pass through point P now that it has changed its velocity. So we want to know when submarine B will now intersect this point. Okay, so I'm going to take the origination point, which was 0, 3.2, and negative 2 for submarine B, and I'm going to take its new direction vector, which is negative 0.45, 1.08, and 0.09, and go ahead and find the value for which that would be true. Now we know it will connect with that point, so all we need to do in this case is just take one component. So I'm going to take the x component and I'm going to solve for negative 2 is equal to 0 plus t times a negative 0.45. So negative 2 equals negative 0.45 t. Therefore, t is equal to, I think that ends up being, let's see here, 49ths. Yeah, if you bring that into a fraction and reduce, you get 49ths hours, which ends up being 4.44 hours later. Okay, so it allows vector or submarine A to pass through that point since it's slowed down, and then 44 minutes later, or approximately thereof, we would see that submarine B would pass through the same point. Okay, interesting question here in part D, 5 marks. It's the biggest part of this problem, but it says find an expression for the distance between the two submarines in terms of t. Okay, so distance will be, oops, I want to use a different color. Overall distance will be the square root of the difference of the x's squared plus the difference of the y's squared plus the difference of the z's squared. So if I took the x component of submarine A, I had 2 minus t. The y component of submarine A was 4 plus t. The z component of submarine A was negative 1 minus 0.15 t. And then same thing for the y, or for submarine B. This is headed in the direction that you will need your calculator. plus 1.08t. Okay, this is assuming the direction adjusted for submarine B. Okay, it's not perfect, but you get the point. Okay, this simplifies down to the square root of 2 minus 0.55t squared plus 0.8 minus 0.08t squared plus 1 minus 0.24t quantity squared. All right, and what I would do is I would type this thing in as y1 in your calculator, right? All that stuff all the way through. Okay, that would be the expression. You can leave it just like this. For the distance, of course, this will be distance with respect to time between the two submarines. So in part E, it has to find the value when the two submarines are closest together. So you need to start thinking, how am I going to use calculus here? Because this would be where d prime of t is equal to 0. Okay, and there will likely only be, well, there only will be one spot where the derivative of distance, you could also note this as dd dt is equal to 0. Because both are linear, the distance between them will, it will converge, and then it will start to diverge from each other. Not to confuse that with series, but because they're linear and not moving in any sort of zigzag pattern or anything like that, clearly there will be a minimum distance or closest distance. So if you use your calculator, you type, of course, your distance formula in for y1. Actually, what I think is a really good helper is if you type in for y1 dt, right? Just type that in. In y2, if you do math, well, you don't want it to go in that way, but if you typed, if you did math 8 and then put the derivative, so it would be like d dx, put in y1, and what it'll do is it will ask you for where x equals something, put in x. And this right here is the derivative of the first function for all values x. Okay, if you do that and you type it in and then you go back to your home screen, and you graph it, your calculator will graph this new red function, and you'll be able to see where it is that the two submarines are closest together. Your calculator, I believe, if it gives you what I got, will, to 3 sig figs, tell you 3.83 hours. Awesome. All right, now part F, I believe, is find the distance between the two submarines at this time. All you do is on your home screen, press Y1 or go to vars, however you get to Y1. I believe you can also press alpha trace and pull up Y1 and then just plug in 3.83, and you should get out 0.511 kilometers. Okay, of course, using the calculator. That's an easy one marker. Same thing with 7E. Very accessible, and especially with the use of the calculator, you can kind of work around some of that stuff as well. So that's it for problem number 7. I hope this went well. Shoot me some questions if you got them.